So now we are talking about the flow system of level measurement. Flow system. All of you know about floats. Floats. You put water down. Then you carry something that is very light in weight. Lighter, than water. And you drop it on top of the water. What happens? It stays on top of the water. It floats. Floats. So this system has been used to develop a level measurement system. The flow system. How does it work? You have a storage tank, then a float is mounted on it, such that when the quantity of liquid in the tank goes up and down, it carries the float up and down accordingly. You understand? That float is mechanically connected to a potentiometric transducer, a potentiometer. You remember what a potentiometric transducer is? A transducer that measures changes in distance, or what we call displacement. Changes in displacement. So that is why they call it position transducer. It's a position transducer. So that when the level of fluid goes up and down, the transducer transmits various level of resistance to the system. It changes the value of resistance on the potentiometer. Now the potentiometer wiper is the one that is linked to the float. Okay? We have something here, a float that is going up and down. Okay? Okay, that float is connected to the wiper of the potentiometer. Okay. This is the liquid, and we have a float. Okay, so I moved it down because of the space. I just needed more space up here. That's why I moved it down. So we now have the circuit connected to DC supply. Okay, then we have as a bigger picture, we have the meter somewhere here. Okay, and the meter is linked to the circuit from here. So what you now have is this. We have the voltage here as V. We have the ammeter, that is the level indicator. Level indicator. Now, instead of calling this ammeter now, we call it what? Level indicator. So the fluid in the tank will be carrying these floats up and down. As the float is being carried, don't forget, the wiper of the potentiometer is coupled to it, mechanically coupled to the float. So the float will move it up and down on the resistance here, resistance R. And that varies the resistance in this circuit. And once resistance varies, what happens to current? Current varies. Current varies. And that is what the flow system uses. Now, when the liquid level is low, the float comes down. Then the resistance comes here, for instance. So at that point, we can have low resistance in the circuit. When we have low resistance, what happens to the current? High current. That is reverse, isn't it? That is reverse. Or, if this is constructed such that high resistance, there will be low current, so that we can get lower value of the tank that we have here. But invariably, we've got a system that works. We can vary this resistance by level of the fluid in this tank, going up and down. So this is the liquid in the tank. liquid in the tank. Alright? Now, the voltage output voltage is used in this case now, not the current reading. Output voltage, which is actually a function of this voltage. The total voltage here will be varied based on the position of the wiper on this resistor. This is a variable resistor now. So, the output voltage that you get will be proportional to the level of liquid. So, V output will be proportional to the height of liquid in the tank. So, let's put the height here. This is the height. So output voltage obtained right here is proportional to the height of fluid. When we have high voltage recorded and the indicator, that means level of liquid is high. Highest value of voltage means tank is full. Is that not so? Lowest value of voltage means tank is what? Empty. Empty or low. Very, very low.